Good Wednesday to you again, everybody in Gov 603. Welcome to week 11's Boom review of week 10. This is the video in which we go over what we did last week. I review your answers, bring some insight, so on and so forth. Ooh. Nice latte for the afternoon. Normally, I don't drink lattes in the afternoon, and neither should most people. I think it's like 40% of the world's population is lactose intolerant. And if you add lactose in your system without sufficient time to break it down, then that can give you problems later on in the day. So, now interestingly, the closer to the equator the major genetic line that makes up wherever you came from, the more likely you are to be lactose intolerant. The further away from the equator, especially going in a northerly direction, the less likely you are. I believe part of that reason is that people in the upper northern hemispheres relied on cattle. We're talking like tens of thousands of years here, and their milk as a protein that sustained them through the winter. People that were closer to the equator ate less, ate more plant-based proteins, and so genetically they're not as well adapted to breaking down lactose as those from the northern reaches. So goes the theory. Okay, let's take a look at what you did last week. Now, first things first, you might be wondering, hey, Dr. G, this is a poli-sci class. What's with the questions and the data about COVID? Okay, so why did I use that data set to run through the example of simple linear regression? Well, my guess, we're not far enough away from the event to say this with any certainty. So this is just a guess, a supposition, is that the COVID virus and its presence around the world, and here in the United States, is historically going to be looked at as perhaps the most significant political event of the first 25 years of the 21st century. There was not an event that was as widespread, as all encompassing in terms of its impact, as polarizing in terms of its political ramifications, and as long in its duration as the appearance of the COVID-19 virus. And so, as a means by which to sort of get your hands around some of the raw data about what was and was not driving the severe outcomes, I use this data set. Okay. And I'm not, I'm not taking any partisan side one way or the other in doing it, just giving you the numbers. Okay. Now, in the write-up, let's go to week 10. In that write-up that I gave you, I explained to you in sort of big strokes what coronaviruses were, where they came from, and what's likely to become of them in the future. And that is, they've been around for a long, long time. They're going to be here in the future. You get them every year. And so, by way of political policy, one may, excuse me, it's allergy season, so if I sniffle, you forgive me. One might wonder where the emphasis should be in terms of public health, because if you know that people are going to get a virus, and in fact, vaccination is the preparation of the body in advance of getting the virus. The reason that you get vaccinated is you expect to get the virus, whatever the virus is, whether it's COVID-19 or something else. Okay. So the question becomes, if government entities expect the populace at large to get the virus by, pushing vaccination, what are the causal factors to really problematic outcomes, severe outcomes, that should be addressed? Because you can't prevent people from getting the virus, which I could running through some data on masking. Now, distancing seems there's some efficacy. There's some data-driven causal relationships um, between distancing and lower incidence of viral spread. Masking, the data does not look good. Okay. I mean, except for very, very specialized masks that they wear in a medical setting, a hospital setting, that are form-fitting to the face, masking, the data does not look good. Okay, so I gave you this data set because politically this became such a hot topic, such a hot football. And you want to look at what's driving the causal impact of the virus, because once the virus gets into the population, it's going to spread. So getting the virus is not the main causal impact of the virus. And you might say, but hold on just a second, time out. There's no causal impact if you don't get the virus. True, very true. But once the virus is introduced into the populace is going to get the virus. Okay, so that's why I gave you the data set. That's the rhyme and reason. All right, let's take a look at the questions. Question number 1, I asked you to look up what the R values in a linear regression mean. That is R and R squared. And tell me a little bit about that. Nicole, let's see what you said. Linear regression value R, otherwise known as the correlation coefficient. I want you to remember that. Correlation coefficient signifies the correlation of relationship between an independent and a dependent variable. The R value ranges from -1 to +1 and indicates either a negative or a positive relationship between the independent and the dependent variable. Okay, so what are we talking about here? Good answer, Nicole. Let's just translate that very quickly. Remember when we were discussing the components of a hypothesis? The hypothesis has at least 2 variables, makes a prediction about the relationship between the 2 variables. That's the second thing. And the prediction has a direction. All right, that is the R value. Is there a positive correlation? Is the one driving the other? Or is there a negative correlation? Is the other driving the other in the other direction? Or in the case in which R equals 0, and I can tell you it's exceedingly rare to have R absolute 0, an R that equals absolute 0. Why? Because there's a lot of what you could call background noise going on in statistics. It's the same, the reason that we discussed and you read about as to why you cannot have a single causal explanation as to why Van Gogh chopped off his ear. Okay, because people are complicated and there's multiple, reasons, variables, multiple factors that drive human behavior. Okay, the same is true in any other behavior. So you have other factors that you may or may not be aware of. So it's rare that you get an R that equals 0. But and the R is expressed in percentage, point something of 1. Okay, leading up to 1. Okay, so Nicole, if the R value is close to -1 or 1, the value is higher. Thus, the independent variables have a better relationship. If the R value is 0, there is no relationship, meaning there's no effect from one to the other. Initially, the R value is what percentage of the relationship between the independent and dependent variable. Okay, so knowing that as a given, if you see a negative, and when I asked you to post your charts, we'll get to that in question number 3. You can tell just by looking at the chart if you're going to have a positive or a negative R value. If the line slopes up from left to right, that is starting at the y-axis and then sloping up along the x-axis, that indicates a positive R value. If the line slopes down, that is starting at the y-axis and sloping down from left to right, you're going to have a negative R value. Okay, so that's what R means. What about R squared? Okay, linear regressions R squared, otherwise known as the coefficient of determination, remember that too, signifies the variation in the dependent variable accounted for by the independent variable. Okay, let's translate that in English. R squared is an extremely important value, and it's just where you get R squared, you just take the R value and square it. There's times it by itself. What R squared tells you is whatever the outcome, the dependent outcome, what percent of that dependent outcome is being caused by the independent variable. And this is expressed from the value of 0 to 1. So none And again, an R squared of 0 is extremely rare. I mean, you could find it. You just pick two random things and throw them into a calculator. Like, these aren't related at all. And in statistics, R squared is often discussed as weak, medium, and high. So if you have R squared values that are down in the 10 percentile, 0.1 something something, because it's a percentage of the number 1. Okay, so if you have a hard time with that, think of it as like a dollar. 1 as $1, then you have pennies leading up to $1. Okay, so if you have an R squared value that's around 10, they'd say that's a weak causal relationship. All right, if it gets up towards 30, 40, half of 1, you say that's mild. Okay, anything above 50 and then on up, and then you get into the 70s and 80s, that's strong. So most of you, if you ran the simple regression calculator correctly, we're getting R squared values really close to 1. 0.8 something, so 80% of 1, 0.9, 90% of 1. So that tells you there is an extremely strong relationship that is, almost 100% of the outcome is being driven by the income. 100% of the dependent variable, say the severe outcome of COVID-19, was being driven by the independent variable, in this case, the independent variable being the comorbidities. Okay. That's what that number is telling you. Okay, so that takes us to question number 2. What do the R values, R and R squared, you found for both regressions suggest about the relationship comorbidities and severe COVID-19 output? Mohammed, let's take a look at you. And many of you, listed your R values, and that's fine. What I'm really asking for is, well, what does that tell you? Okay, so let's take a look. You listed both here, age group 0 to 17 with deaths, and then age group 50 to 59 hospitalization rates. Let's take that because that's my age group. Second regression analysis explores the relationship between comorbidities of individuals ages 50 to 59 hospitalization rate outcomes. Correlation coefficient R is 0.9968. Now, really important in this, Mohammed, is for you to tell us what's the independent variable here. Is that 0 comorbidities, 1, 2, or more? Okay. Because just an R number by itself doesn't give us the picture as to what's the relationship between what and what. You got to give us the what and the what. Okay. And given that number, that is 0.9968, I'm going to assume that's 2 or more comorbidities, indicating extreme strong positive relationship between comorbidities in individuals is 50-59 a hospitalization rate. In other words, the number of comorbidities in individual, as the number of comorbidities in an individual increases, there's a nearly perfect positive correlation with hospitalization rate. The R squared for this is 0.9937, meaning approximately 99.37, which is, statistically speaking, 100% of the variation in hospitalization rates among individuals 50 to 59 can be explained by comorbidities in this age group. This high R squared value demonstrates comorbidities are exceptional predictors of hospitalization rates. Okay, excellent. So in other words, you're looking at these numbers. Now, what I'm looking for, and you may see on a test, is the spread between, say, 0 comorbidities and then the severe rate, and 1 or 2 or more comorbidities and the severe outcome rate. Okay, so you want to make sure that you do that. Okay, question number 3. I asked you to screen capture and post your scatter plot and your R values for the data that you picked, and all you folks, you got this. That's great. Let's take a look at, say, Melissa. Okay, so you did percentage of death rates, comorbidities, age 30 to 39, and then percentage of hospitalization rates, ages 40 to 49. Okay, fine. Now, the graph that you're seeing, this is a very simplified scatter plot graph. And what I mean by very simplified is that because there is only 3 points of data on it. You could, using this calculator, take data that had, you know, multiple independent variables and put it all the way down and get a much more dot populated dot matrix. Now, this calculator, this simple regression calculator, does you a nice favor. Most times in scatter plot graphs, you don't have a line. You just get the distribution of the dots, and then you have to take a ruler and find where a sort of a midline is. Look, you know, you sort of squint your eyes and see how the dots cluster, and find where, if you could draw a line, there'd be sort of equal distribution on one side of the line, another, and go, and that gives you the slope. That gives you the strength of the R value in a visual, not a number. This regression calculator, you know, nicely gives you the line. Okay, so when you see the line that tilts in an upward direction from the x-axis to the y-axis, all right, that tells you that's a positive R. If it's basically flat, that tells you R is 0. If it points the other way, that tells you R is negative. Okay, so looking at, say, percentage of hospitalization rates for 40 to 49, we see that with 0 comorbidities, the hospitalization rate is way down here. It's like close to 5%. I think it's about 7% looking at the dot on your graph. And remember, anything 5% or lower is statistically insignificant. Okay, if your confidence interval is 95%. Now there are some, and that's standard for human behavior. So if you're doing research in political science and you want to say there's significance, there's something going on in human behavior, this thing is probably causing that thing. Okay, the relationship has got to be 5% or greater. All right, so if it's 90, remember what we said before, 95% of the time and up, if the predicted ordered existence of reality continues as is, there's nothing interacting on it. So for instance, all right, I want to make sure you understand this is an extremely key concept in statistics. You take a quarter, upside down. Okay, let's take a quarter. And if you were to flip this quarter, ka-ching, 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 and you an assistant, and the assistant flipped it, and you recorded, you flipped it 100 times, 10 times. So a total of 1,000 flips. You've got some time on your hand. I don't know why. Maybe it's raining out or something, okay? And in groups of 10, or groups of 100, 10 times, you wrote down whether it was heads or tails. All right. If the distribution between heads and tails 95% of the time is not equal to heads and tails. So instead of, like, you know, let's say 100 flips, it doesn't have to be 50-50, 50 heads to 50 tails. Let's say it was, you know, like 56 to 44 or 58 to 42, whatever. Sometimes heads, sometimes tails. If it stays in that 95 percentile, the ordered existence of the universe is proceeding as expected with nothing acting on it. If the distribution between heads and tails drops below 95%, let's say, you know, you're like, oh, that's weird. We flipped this 100 times, 10 times, so 1,000 times total. And when we totaled it up, it turned out between all those 1,000 flips that it was a 70% distribution between heads and tails. This tells you, as a researcher, something is acting on this coin. Maybe it's a trick coin. It's heavier on one side than the other. Maybe your assistant is a knucklehead, and when she sees heads, she says tails, or he sees heads just to mess with you, he says tails. Some other force than just the expected ordered existence of the universe is acting on that coin. That's your confidence interval. Excuse me, bump the camera. 95%. Now, in certain, this is human behavior, you know, sociology, communication, political science. In certain fields, like pharmaceuticals, the tolerance is much, much tighter. 98 is the starting point, and depending on the drug the tolerance is even tighter, 99. If you have more than a 1% outcome beyond what you expect, someone grows like a third nipple or something when you give them a drug, that drug isn't making it anywhere to the market. Okay, so your confidence interval is much, much tighter. In the social sciences, 95%. So back to your graphs. All right. So starting to ages 40 to 49, it's a little over 5%. So if we map that as that would be probably like a 93% confidence interval, 7%. Okay, so there's something going on with zero comorbidities for that age group, but not much. But then you get to one comorbidity, okay, and the hospitalization rate jumps up around 25%. And you see that number one directly under that dot. That's significant. Now you're looking at like 75% to 25%. Something is definitely, there is a causal relationship between the comorbidity and the hospitalization rate. And then you get to the 2 or more, and now you're up to 50%. Okay. So when you see a graph like this, you see a scatter plot graph. If you don't have a line, that's just the statistics engine not doing you any favors. Print it out, draw the line yourself. If it's sloping up, you're going to know that there's a positive R value. If it's flat, you'll know it's 0. If it's going the other direction, it's a negative R value. And then looking at the R squared that you put here, Melissa, R squared for now again, you got to you have to, and I'll have this on the exam. You have to say the R squared value you have is 0.993. Is that the R squared value for 2 or more comorbidities? Okay. And if it is, that's fine. Okay, then just say so, because the R squared value for, say, 0 comorbidities or 1 comorbidity is going to be different. All right, so because I can see, it's very, very high. Let's assume that it's for 2 or more comorbidities. It's 99.3. That's almost 100% of landing in the hospital if you were ages 40 to 49 is being driven by as a severe outcome to COVID, being driven by having 2 or more comorbidities. Okay, question number 4. Recall your experience of the 2021 COVID pandemic. Do you recall the immediate emphasis on a causal relationship between severe COVID-19 outcomes and comorbidities? Why, in your opinion, did the media cover or not cover this relationship? Okay, now this was one where I gave you some latitude. What do you remember? Okay, there are a number of you had very, very interesting answers. Megan, I remember when COVID started, I was an undergraduate. It was during spring break. The news was talking about how deadly it was and how spreadable, telling everyone to be careful. And I was worried that everything was going to close. In fact, I called the university and asked them about it before I left the dorm to see whether I should clear out before leaving. And they said, no. Before spring break was over, they called and told everyone we had to get our things out the following week, which required many of us to travel from other states. It was very frustrating. The news was very dramatic, making it seem like the world was ending. Okay, now right there, and this is why I gave this to you as a consideration for political science, because if we look at the data, and by the way, these simple regression analyses, you can do this for the common flu and get similar results by way of severe outcome. Okay. So if we had been looking at the data, all right, and reporting on this virus driven by the data would suggest that this is only a severe risk to you if you land in certain categories, that is, in higher ages with comorbidities. Let's say existing comorbidities, but that's redundant because that's what comorbidities mean. Okay. So we could have said, if you're in these age groups and you don't have any of these pre-existing conditions, this is not, I mean, you don't want to go out and get any virus. Okay. But this is not the end of the world. For my group, I'm 59. Okay, I have zero comorbidities, and I'm actually in very, very good health. My chances of a severe outcome from COVID-19 were about the same as my chances of being killed in an automobile accident in the least populous state in the Union, that is Wyoming. And since that year I was driving through Wyoming, it never occurred to me, oh, I shouldn't drive through Wyoming because maybe I will be involved in a vehicular accident that will cost me my life. I gave it no more thought than I did driving through the state of Wyoming. Why? Because I had the data. But let's go back to you, Megan. They told everyone not to travel or go outside because you might get this incurable, deadly disease. I did not listen and I did not believe them from the start. I looked at the actual symptoms and death rates, which I compared to the flu. The flu was more deadly. My doctor said that because I have type 1 diabetes, see now, and Megan, and I, since you've shared this with us, she has an existing comorbidity, that it would be more deadly to me, which was true. Okay, because that's a comorbidity. So she's on that one line. I do remember the news saying that if you were older or a child, it would be more deadly. And actually, by way of that other group, the children, that's not true. If you look at the data, the younger you are without comorbidities, it's almost like meh. Okay, but but they say that about everything because they are vulnerable ages. When it came to vaccines, they emphasized that people with comorbidities needed to get it. But my doctor told me not to get it, that it could cause more issues than COVID itself with my comorbidity, which is also true. And that's not something we got into in this exercise, but that's true, Megan. Overall, from my recollection, the news did not emphasize comorbidities in relationship to COVID until it came time for the vaccines. Okay. All right, let's see. Haran, you had a very interesting answer here. In all honesty, COVID-19 was a comeback to Jesus moment for me personally. I often get so caught up with my work that I miss the mission. And this pandemic put me back on my mission as well as on my knees. I actually do not recall the media mentioning causal relationships between COVID-19 and comorbidities initially, but I thank God my wife, who's a healthcare worker with over 20 years experience, that firmly believed in holistic approach to almost everything, or our family approach, I think you meant, this pandemic from this perspective, and actually found ourselves in a favorable in our favorite tractor supply stocking on ivermectin. And by the way, for anybody that points a finger at Haran, and I'm not, it's not a political thing. Ivermectin is one of the world's most widely used drugs. It has been praised for years and years and years for a number of things, including the slowing down of the process by which a virus replicates itself. It's not antiviral. In fact, there are no medications in and of themselves that are antiviral. There are medications that help your system deal with the virus, but ivermectin, and I won't go into the pathology, but ivermectin has been proven in a number of instances with viruses to slow down virus replication. Okay. Stopping of ivermectin very early on, alongside other homeopathic immune boosters that I will not list. And thank God my household was spared that pestilence. As far as the mainstream media goes and their lack of establishing causal relationships in COVID-19 and outcome of comorbidities, I have to be honest, with my background as a prepper for over 2 decades, I have a very unique perspective concerning many things that we are currently witnessing, and I will not elaborate too much and potentially be labeled a wee bit strange. I think it's too late for that, Haran, but we love you, baby. But I will refer you to one of my favorite Bible verses, I believe fits. That is Ephesians 6:12. For we wrestle not against flesh and blood, but against principalities, against powers, against rulers of the darkness of this world, against spiritual wickedness in high places. Okay, interesting answer. So in other words, you're saying, no, you did not hear a lot about this. Now, some of you said that you did. I think Helen, you mentioned that, you remember hearing some stuff about this. From my recollection, I'll chime in on this question. I did not. And at that time, I was very, very focused on the data and what was going on. It's just schedules. I was writing for an international newspaper in the health and wellness section, and I was writing about this, and sorting through media stories and sorting through CDC bulletins, and the discussion of the relationship, the causal relationship between severe outcomes, which is really the only question when it comes to a virus. How do you prepare your body for when you're going to get it? I mean, that's the purpose of a vaccine, preparing your body for when you're going to get it. So the central question is, how are you prepared, you and your system prepared for when you're going to get something? And looking at those threads, I found very little, very, very. I didn't say it was wholly absent, but it was very little. Now the question is, why did the media not cover that relationship? Okay, and that was an area in which I don't know if you didn't understand the question so much as you kind of punted on it last. So I'm gonna chime in with one more person here that sort of did touch on that part of the question. Nicole, the general media coverage seemed not to have covered this causal relationship, since their focus seemed to be on educating the public on the risks of COVID-19, specifically how COVID-19 was causing millions of deaths worldwide, how people can stop the spread by wearing masks and getting vaccines. Okay, which ironically, you don't stop the spread by getting vaccines. You prepare your body for when you get it. Many people did not know much about COVID-19 when it started, so they were naturally curious about this new disease and its effects. Thus, the media picked up on people's natural curiosity and focused on the dangers of COVID-19. Could get them to watch, which resulted in further hysteria and fear due to the media reports. I think Nicole, that without playing sort of Monday morning quarterback, as the saying goes, wow, I would have done this, some of this, but you put your finger on it. Long data discussions about the causal relationship between comorbidities and severe outcomes. These don't get the clicks, and they don't get the eyeballs, and they don't get the ad money. Scary stories about millions of deaths and an unfolding apocalypse. Now you have people's attention, and now you have clicks and views. And I'm not being cynical. I'm telling you that both within media and politics, okay, back to you again, there is a significant player in the room when it comes to the commercial aspect of why media and politicians, and the relationship between politicians and media do what they do. Okay. All right, everybody. Make sure that you've watched the video about what we're doing this week, because I've got a bonus question in there for you. Instead of 4, I'll give you 5, so you can take a look at that. Keep on keeping on. Remember, work on those papers. All right. If you have questions or issues, remember to email me, because I'm here for you. I want to see you succeed. All right. Think about you. I pray about you. Have a wonderful, wonderful rest of the week, and I will see you on Canvas. Bye-bye.